All right, so in this section of the book, I think we're going to be looking at adding and subtracting polynomials, yeah? So I think that this basically is all about like terms. There's only one time where you have to be really cautious, really careful, or you really mess up algebra from here on in. Okay, so I'll make that real clear, try to make sure that you guys don't mess it up. See what happens. All right, so sometimes when you're working with problems like this, they're going to specify that the polynomials are separate polynomials. Which one of these problems does it really kind of specify that you have one polynomial added to one other polynomial? Can you guys tell me which ones? Is it 1, 2, and 3, or 4, 5, and 6? Yeah, Mary? 4, 5, 6? Yeah, see over here they kind of specified. How did they specify that we're really taking one big polynomial expression and like adding it or subtracting it to another? The parentheses, right? So I don't know if those parentheses so much matter except in one case. So that's one thing I want you to be real clear about. These first couple problems, we don't know exactly which polynomial is which. It's kind of just like one big long polynomial. So they must just be asking us to look for anything that can be put together. In other words, any like terms that there are that you can put together and make it a little simpler so it reads easier. Does that make sense? Because it's just a bunch of monomials. So look at number 1, guys. Are there any kinds of objects, algebraic objects, that are the same? Yeah, which ones? The cubes and the squares. Right? You say it funny. I think that's the way you should think about this, though. So the cubes and the squares. I think Richard's referring to this. Lots of you guys kind of saw those, right? Oh, and I should really always circle the thing in front, too, when I do that, right? Because the coefficients always stay attached. So you could, of course, waste some time and write this down with the things next to each other, but I don't think that's necessary. It's a waste of time, okay? So when you're doing your assignment, make sure you write down the original problem, and I think you can go probably straight to the answer on these kind of things. Up to you, though. So how many of the cubes and the squares do we have? There's 2 terms, but how many cubes are there? There's 2 terms of them, but how many of them are there total? Kayla? Huh? 6? So you're telling me 14 of them and 8 of them is 6? 14 of them and 8 of them is 22 of them. So what I'm really hoping for is to convince you that should this be x to the 6th power here? No, because we're not multiplying. There are cases where you're going to multiply things. That's going to be later this week. And yeah, then it's going to change what it is. But when you're just looking at how many of something there is, like terms, you're just not changing what they are, right? They are x cubes in that case. And what are these? These are x squareds. How many of them are there? Well, we've got 7 of them and negative 11, so you should read it. 7 minus 11 is negative 4 of them. Notice they do not change their identity. They stay what they are. That's one thing that's always a temptation with basic algebra students, is to change what they are. Well, it's not multiplying here, so they can't change. Now, if you multiply cantaloupes times apples, maybe you get some kind of new fruit. But if you've just got 7 cantaloupes and 5 apples, you've got 7 cantaloupes and 5 apples. You can't change what they are, right? So. Huh? Yeah, totally. So then you might get into crossing stuff. Those are called genetic crosses. Well, cross involves like multiplication or something like that, right? Or something more than that. Okay. So, what do you guys think? What's the same in number 2? Is anything the same? Can we put anything together? The 6p and the 3p, that's it, right? So everything else stays what it is. So I'm just going to write down the other stuff. Write it in descending order. That should be a reflex already. These are the same, though. So how many of them are there? There's negative 9 of those guys. And then we've got an 8 and a 5p squared. Okay? So when you look at this in your head, I think you should be practicing already. You don't have to write it down if the directions don't say, but you should be practicing. This is what kind of thing? Somebody name it for me.
The quartic.
3 is not quartic. That's 4th.
Oh, that's the quantity.
That's cubic. 2 terms is
Oh,
binomial. Okay, so you should be doing that in your head. If you don't already comfortable with it, you should know. Okay, so Sierra, degree 2, what's that mean? We're going to study these a whole bunch, so you've got to know the names. This guy's quadratic. trinomial. So if you're not already comfortable with that, every time I'd be practicing it in your head. Okay? All right, so that's it. This last one, number 3, are there any terms that are the same? Or are they all the same? They could all be the same, possibly. They all the same kind of thing?
No.
No? Which one's not the same, Richard? This one's not quite the same. It's close, right? So it's going to just have to stay chilling over there by itself. But these guys are the same kind of things. They're m squared y's. How many m squared y's do we have? I know there's 2 terms, but how many of them? There's 14 of the m squared y's, minus 8 the other things. So that's it. Okay? So what about the situations where they have these parentheses delineating you've got one polynomial times another? Well, is there anything to distribute out in front of this one or this one? Anything to distribute anywhere, guys?
No, it's just one.
No, so this is really just a thought process that you're supposed to think about. If I add that quadratic binomial to that quadratic trinomial, what do I get? That's kind of the thought process behind this, okay? So really, do you even need the parentheses on those?
No.
No, so in your problems, I'd just go, or you could write it down again, but I'm being lazy, I'm just going to erase. Okay, and it's the same game we just played. So what's the same, what's different? Well, I think you guys can get it now. There's these 2 that are the same. There's 5 of those. Nope, just x by itself. And we got a 9 and a 6, that's 15. So there you go. So that situation, I get a quadratic trinomial. That's what you should say to yourself in your head. Okay, this guy, if I take this quadratic binomial and this quadratic tetranomial, if I add them together, again, just ask yourself, is there anything to distribute in front of either one?
No.
If you distribute a +1, I mean, nothing happens, right? So I don't think there's any reason for these parentheses even being here. So you can erase them or just not write them down to begin with, right? Okay, and then you just play the same game. What's the same, what's different? I see lots of squareds that are x's. These and that one. So I've got 9 of them minus 10 of them. It's like I owe my friend 1 of them for some reason. And then these ones are the same too, right? I guess I could get a different color. What'd you say, Richard? How many? -4. So I'm going to do this, -7, yeah? -7 and 3 is -4. You got it. Thank you. And that's it. Okay, we good? This is pretty simple. Number 6 illustrates kind of the one pitfall that you could experience, and this is key. Like my students in Algebra 2 are working on very similar kinds of things right now. Sometimes I throw one just like that on their quiz just to see if they can still do it, because it's very important. This is an opportunity for one of the biggest algebraic mistakes. Can I just erase these parentheses?
No, you have a negative.
It says subtract this quadratic trinomial, take away a quadratic binomial from it. So you said no, Richard. Can I erase either set of parentheses? You should read this and be like, okay. Yeah, I can erase the left one, because is there anything distributing the left one? You guys see anything out here? Or out here? No, that's attached to in front, right? So these I don't need. That's just a hole in my board, sorry. It's like a bullet hole. Somebody shot my board before I got here, like 7 years ago or something. Don't ask me, I don't know. Okay, so I don't think we need those. Do we need these parentheses? Yeah, because something's being distributed here, whether you see it or not. What's being distributed? -1. So you need to make sure that whenever you see that, you distribute the negative. Very important. It's very simple, but it's easy to forget. So be careful. So I'm just going to write it down one more time on this one, being very careful, as you guys should. Every person in here, even those who skip a lot of things. So distribute that. A lot of people are going to miss that this now is a +10. Okay, it's very simple, but I'm telling you, you'll mess it up if you're not careful. Now I just play the same game. Okay, so what's the same? Well, these are the same. Looks like there's -12 of the m squareds. M's are chilling on their own. And I've got 18. There we go. Okay, so you guys are like, come on, Mr. McGee, it's so easy. But You make that mistake if you're not aware. If you don't have what they call on Friends, you guys anybody watch Friends?
I love Friends.
It's this great episode of Friends where Ross, everybody's favorite character to hate, right? So Ross has this episode where he's like, unagi, the state of constant awareness. That's what you gotta have here. You gotta have unagi, which is actually, of course, eel sushi, but Ross is a know-it-all, so. Gotta have the state of constant awareness to make sure you distribute those negatives, okay? All right, let's do one more of those just to make sure we're solid. Why don't you guys try this one on your own? Let's see. Okay, so try that one on your own. If you're watching the video, I'd pause it. Okay, so this is another case of I can erase one set of parentheses. Which one is it? Joe, what do you think? Which set can I erase? This one? There's a -1 being distributed. You mean this one? Okay. So over here, I can erase those. The only reason they were there again was to specify what? That it's separate, kind of. That we're adding this big thing to that big thing, or except, I should say, subtracting. Okay? So I really have a -1 here that needs to be distributed to everything. All right? So you should have, oh, where'd my blue go? Okay. Here we go. So this is the same thing as, so you can write equals on these. So that times that changes it to negative, it changes that one to positive, it changes that one to negative. Then you play the what's the same, what's different game, just like you did in Sesame Street when you're little.
So I think these are the same.
No? 2 minus 6, -4 of those. Got it. So you can cross them out if you like, that's a good way to keep track. And I've got the y's, lots of negative y's, -21 in fact. And then we've got 9 and 4, it's easy, that's just 13. So there we go. So I got a quadratic trinomial. Good? Okay, so I think you've got a couple geometry questions. So all we're going to work on tomorrow, you'll have some work time to keep finishing this up. But we're also going to do a little bit of geometry review of stuff that I think you should know from middle school, but I'm just going to make sure. So like area and perimeter of squares, rectangles and circles. I'm just going to make sure you're solid on all that stuff. Triangles, I don't know if we have triangles come up tomorrow, but yeah, triangles you should know, sweet. Okay, so here's something else you might need in geometry. What if you have angles? So you might get asked a question like this. So like if you have a straight line, the two angles, the one I have in pink here and the one I have in blue, anybody know? I'm not sure if you guys know, probably not. Does anybody know what it's called if you have a straight line and those two angles? Those two angles, if they're on a straight line, what do they have to add up to? They do have to add up to 180, just like inside a triangle. So really, any triangle, if you break it apart and you look at the three angles, they're really just a straight line if you add them all up. Now that's a fun exercise to do in geometry, okay? These are also called, so you might write this down, angles that add up to 180 are called supplements. So the pink and the blue here are supplementary to one another, okay? So that's another thing you should kind of have in your tool belt, make geometry easier. All right, so all I want to do here is find the total. So I want to find what these guys add up to, so I'm going to write that down. So the problem said, I think, find the polynomial that represents the total angle. Okay, so I'm just adding them up. And since it's just adding, I don't have to worry about the tricky distributing a negative, right? So it's just the same thing. So this is real easy. I've got 8x squared, 12x, and those two are 13. Now, if we were going to try to actually do this problem, we'd have to set it equal to what if we wanted to solve for x and find out what those angles are? If we wanted to find out what these angles are, because they're unknown right now, this thing would have had to been set to what? You guys told me a second ago.
8 and 3 is not 13.
Very good. Never trust my arithmetic. I've said that, haven't I? So, yeah. If I want to actually solve for this and find x, I've got to set it to 180. So down here, it would also be set to 180. The problem is, you guys would know how to solve for x if that wasn't there, right? We did that last semester. If this wasn't there, you'd go minus 11 on both sides, and then I think you'd have to divide by 12. You guys could totally find x and stick it back in, and you'd have your angles. Cool? But did we learn how to solve quadratic things yet with squareds? I don't think so. So that requires a lot more knowledge. That's where we're trying to go next. Square root. Can you solve this by just using square root? Very good idea. Square root does get rid of squared, but you couldn't do that on this problem. Like, it'd require a lot more. So that's what we're going to get to next, okay? So I think this equation is something we still can't do, but we're going to get to real quick. Square root's a good idea, but not quite enough.